Artificial intelligence, or AI, and machine learning, or ML, are terms that frequently appear in today's tech-driven world. They are often used interchangeably, yet they represent distinct concepts in the realm of computing. AI refers to the broader idea of machines being able to carry out tasks in ways that we would consider smart or human-like. Machine learning, a subset of AI, involves giving machines access to data and letting them learn for themselves without being explicitly programmed. AI and ML are reshaping industries, enhancing our ability to process and interpret vast amounts of data and solving problems that seemed insurmountable just a few decades ago. From dynamic search algorithms to autonomous vehicles, the influence of these technologies is pervasive, demonstrating their potential to transform our daily lives and work routines. Understanding these terms accurately is crucial for anyone looking to engage with or develop these technologies. As we delve deeper into this essay, we will explore the nuances of AI and ML, their applications, and the ethical considerations they entail. By the end, the aim is to demystify these complex but fascinating areas of study. AI and ML are not just about technology. They represent a leap towards creating systems that can reason, adapt, and act autonomously. As we proceed, we'll uncover how these systems learn from their environments and make decisions, fundamentally altering the landscape of possible machine capabilities. AI is the overarching concept that encompasses everything from simple calculators to complex predictive analytics systems. Machine learning is a specific approach within AI that allows systems to automatically improve through experience. Deep learning, in turn, is a specialized type of ML that structures algorithms in layers to create an artificial neural network that can learn and make intelligent decisions on its own. The distinction between these terms is significant. While all deep learning is ML and all ML is AI, not all AI involves machine learning. Traditional AI is rule-based, using set instructions to perform tasks, whereas ML and deep learning learn from data, improving their accuracy over time without human intervention. Deep learning is particularly powerful and is behind many cutting-edge innovations, including speech recognition technologies, natural language processing, and image recognition. These technologies use complex algorithms modeled after the human brain to process data in sophisticated ways. By understanding these tiers, businesses and developers can better decide which technology fits their needs, optimizing processes and creating more intelligent systems to tackle specific problems. This knowledge is also crucial for regulatory and ethical considerations, ensuring that as machines get smarter, they do so in ways that benefit all of society. Machine learning can be broadly classified into three types: supervised learning, unsupervised learning, and reinforcement learning, each with unique approaches and applications. Supervised learning involves teaching a computer model to make predictions based on example inputs. This is akin to learning with an answer key. Applications include spam filtering for emails and credit scoring, which are based on learning from historical data. Unsupervised learning, on the other hand, involves training a model on a dataset without predefined labels. The model tries to understand the patterns and structures in the data independently. Common applications include customer segmentation in marketing and anomaly detection in network security, helping to identify unusual patterns or outliers without prior knowledge. Reinforcement learning is modeled based on decision-making processes. This type of learning uses algorithms that learn to achieve a goal in complex, uncertain environments by trial and error. Examples include robotic hands that learn to manipulate objects and software agents that optimize trading strategies in financial markets. Each type of learning has its strengths and areas of application, making ML a versatile and powerful tool across various sectors. By leveraging these different types of learning, AI can be tailored to meet specific challenges, enhancing both the efficiency and effectiveness of solutions. The process of developing a machine learning model involves several critical steps. Data collection, data pre-processing, choosing a model, training the model, testing and validation, and finally deployment. Each step is crucial and must be executed with precision to ensure the effectiveness of the final model. Data collection can vary from gathering user data through apps to capturing images for a computer vision system. The quality and quantity of data collected significantly influence the performance of the ML model. Data pre-processing then involves cleaning and formatting the collected data into a suitable format for analysis, dealing with issues such as missing values and outliers. Choosing the right model is based on the problem at hand and the type of data available. This could range from simple linear regression models to complex deep learning networks. Training the model involves feeding it data and allowing it to learn from it, adjusting the model parameters to minimize error. Testing and validation involve evaluating the model's performance on unseen data, ensuring that it can generalize well to new, unseen scenarios. Deployment involves integrating the model into the existing production environment, where it can start providing insights or making decisions based on real data. Each step in this process is interconnected, requiring a careful balance between technical expertise, business understanding, and strategic planning. This systematic approach ensures that the developed ML models are not only accurate, but also robust and scalable.